form is just f of x equals x squared.
But if it doesn't have the other two, isn't this going to be 0?
Well, it does have the other two. They're just not written because b equals 0 and c equals 0. Okay? Just like when we had an equation y equals mx plus b, if there was only a mx, we said, well, then that means b is 0.
But whenever you do negative b over 2, everything come out to 0. So how do you
Your vertex is on the origin. We're going to get to that. Okay? This is how this is going to help us. Because this is going to give us 2 more points on this graph. All right. Now I lost my train of thought. X-intercepts. What is the value of y when you're crossing the x-axis? 0. So if we're going to find the x-intercepts, we need to figure out what is x when y, and this is the same thing as y, right?
Yeah.
Equals 0. So we need to solve this equation for x. Now, the way we've been solving equations so far when there's an x squared term is we simply got everything else on the other side and we took the square root, correct? But the problem with doing that now is if I get everything on the other side and take the square root, I'm going to have the square root of x on the other side. Well, how do we undo that? Okay, well, let's square it. Okay, well, then I'll just have x squared again on this side. So it's like a never-ending cycle that you can't get yourself out of. So the way we solve these equations is to make x have an exponent of 1. And the way you do that is by factoring. Look at this binomial. X squared minus 6x. And think back to our factoring chapter. There were bunches of ways of factoring. The very first one was called the greatest common factor. The first thing we should always do is look to see if there is a greatest common factor. Is there? We're not worrying about the equals 0. I'm simply worried about what's on the right-hand side. X. Both of those terms have an x. If I factor an x out, I'm left with what? X minus 6. Okay, now the way we solve this is along the same lines as placing the restrictions on variables in the denominators of fractions. You remember we didn't want our denominators to equal 0? Well, now we want these things to equal 0 because we're trying to find out what is x when y equals 0. That's bills I still have to pay. Go away, you. How do you close that? You can't?
Oh, go to
You pay the bill?
Click on.
Okay. Sorry. I ran into the board. Okay. The concept we go off of here is this. Once I figure out what x is and I subtract 6 from it, I'm going to have one number times another number, and the answer is 0. If you multiply 2 numbers together and the answer is 0, what does one of them have to be? One of them has to be 0. Well, I don't know which one is 0, so I'm going to look at the possibility, what if both of them would be 0? So what we do at this point is we take each one of these and we set it equal to 0 to figure out what are all of our x's. Okay, well here x is 0, right? What's x got to be here if x minus 6 equals 0? X is 6. So the zeros of this function are the x-intercepts of this function are at 0 and 6. Does this function open up or down? It opens up, and it crosses the x-axis at 0 and 6. Now let's use some thought here. It's opening up. It crosses at 0 and 6. Obviously, where's the vertex going to be? Below the x-axis. Okay, we know it's going to be somewhere below because it's opening up and it's crossing twice. Can you figure out just by looking at this where the axis of symmetry would be? Isn't it directly in the middle? In the axis of symmetry, in the center? The axis is just the crease in the middle. Okay, I'm not saying where's the vertex. I'm saying where's the axis of symmetry. Okay, well these are 6 units apart. What's halfway between 6? 3. 3.5. 1, 2, 3. 1, 2, 3.
Wait, how do you get 3.5?
You don't. You don't know math. That's how you get 3.5. Halfway in the middle is your axis of symmetry. So your axis of symmetry is x equals 3. We're halfway to finding the end of the vertex, the other part of the vertex. Because if x equals 3, then how do you find the y-intercept, or the y-coordinate of the vertex? Plug into 3, right? 3 squared is 9. Minus 6 times 3 is 18. What's 9 minus 18? Negative 9. And here's your parabola. You know it opens up. We found where it crossed the x-axis. Now this is handy whenever we have 2 points crossing the x-axis. Okay? So we know that the axis of symmetry is directly in between those 2 points. Once we find that number, we can just plug it in and find the y-coordinate. Nick?
How do you know where that dotted line is?
Because the axis of symmetry is the center of the parabola. And if you know 2 points on either side, then you can find the center. The distance between 0 and 6 is 6 units. The center is halfway in the middle. What's half of 6? 3. So it's 3 units from here and 3 units from here. It's right there. Right smack dab in the middle.
You get 9 by putting it in the problem.
By plugging it into the problem. I get negative 9 by plugging it into the problem.
You put 6 or 0 in there.
You put 3.
Oh.
X equals 3. Okay. Seven x. Sorry. Is this a parabola? Which direction does it open? Where does it cross the y-axis? Negative 15. It's a parabola that opens up and it's crossing the y-axis at negative 15, which means its vertex is way down there. Okay? All right, let's find where it crosses the x-axis. How do we do that? No, that's the axis of symmetry. Let's find its x-intercepts. Let's find its zeros. We set it equal to 0, and we factor the trinomial. Okay, this is one of the, finding the zeros of a function. All right, well, let's do our little trick. 2x times 1x gives me 2x squared, right? Next, I need to look for what? Factors of 15. All right, 3 and 5. I want my stuff to subtract to give me 7. When I cross multiply from top to bottom, 2x times 5 is 10x. 3 times 1x is 3x. Will these subtract to give me 7? And if it's a plus 10 and a minus 3, that'll give me my plus 7, right? If we did this